All right, we're going to take a look at the second section of 9.3. To begin right here, we started 9.3a by taking a look at this circular functions. And there were these set of ratios for sine, cosine, tangent, cosecant, secant, and cotangent, which was, you can see right here, y over r, x over r, y over x. And today, when we're looking at a unit circle in particular, you are actually going to need to know these ratios to find sine, cosine, tangent, cosecant, secant, cotangent. The main reason why we need to know these in order to help us solve things when we're using the unit circle is when a point happens to be actually on the axis instead of in a quadrant. In 9.3a, the points that we were using were actually in one of the three or one of the four quadrants. And remember, we had all students take calculus to help us remember what is positive, which trig function is positive in a particular axis or quadrant. As we take a look at our equation for the unit circle that they have here, there's a few things that really should stand out to you. The first thing is the equation of a circle is x squared plus y squared is equal to r squared. And that is the equation for a circle. So in its most basic form, when the center is at 0, 0, which is the origin. So it says the center is 0, 0, and the radius is 1. So that's why we have right here x squared plus y squared is equal to 1. And that is called a unit circle. So we are going to need to use, once again, the equations that we learned or we just mentioned up above right here. Because what's going to end up happening is that we are going to have our points actually on the axis instead of in a quadrant. So let's take a look right here at number 3. In this problem, it says theta is equal to negative 90 degrees. So one of the first things is remembering, all right, we are dealing with the unit circle. All right. So we have to know that our radius, because it's a unit circle, our radius is equal to 1. So let's take a look. Where is exactly negative 90 degrees? Well, if we start with our initial, remember, if we go counterclockwise, that's going to be, this would be positive 90. We go counterclockwise, clockwise, then that'll be negative 90. So my point happens to be right here. And if we think about this as a circle, remember the distance from here to here would be my radius. And therefore, this has a length of 1. Right, so we could say r is equal to 1 right there. Now, where is the coordinate of this point? Because the distance from the origin down is negative 1, I should know that this point happens to be at 0, negative 1. So think about this. We now know the 3 things that's necessary to be able to solve these 6 trig functions. Right? This 0 is x, y is equal to negative 1, and r is equal to 1, and that will allow us to find our answers. So let's get to that right here. We'll start with sine. So say sine theta. Now remember, for sine theta, we have ourselves y over r. So we have y as negative 1. r is equal to 1, and so sine theta is equal to -1. And we'll go ahead and put this right there. For our next trig ratio, we'll take cosine theta, and cosine theta ends up equaling x over r. So x happens to be 0, r is equal to 1, 0 divided by 1 is equal to 0, and that's cosine theta is equal to 0. Next up, let's take a look right here at tangent theta. And for tangent theta, we have ourselves y over x. Y is equal to -1, x is equal to 0, and hopefully we remember that 1 divided by 0 ends up being undefined. All right, so that'll be our solution for tangent theta. Let's go to the inverse of sine, which is cosecant. So we'll have right here cosecant theta. And we can go through all the business of knowing the equations, but remember, it is the inverse of sine, so we can go ahead and put this as 1 over -1, right? The reciprocal of this. Well, that'll equal -1, so there's cosecant theta is equal to -1. We go now to secant, which is the inverse of cosine, and we'll go ahead and put 1 over 0. Well, 1 over 0, once again, that is undefined. So there's that answer. And then let's go to cotangent theta. And this will be 0 over -1. And 0 over -1 ends up equaling 0. Not undefined this time, unlike tangent theta. And so here are our 6 trig functions. Okay. Let me go ahead. Up next, I'll erase this, and let's take a look at number 4. In number 4, we have, it says theta is equal to 4 pi. Now, remember, when we started looking at our trig circle in 9.192, I said, hey, you should begin to memorize all the different parts around the circle. It's easy for us to say, all right, this is right here is 0, and it's also 360, right? Because they're coterminal angles. Now, when it comes to radians, hopefully we realize that this is 0, but when we go full circle happens to be, and a coterminal angle in radians is 2 pi. So if this is 0, we go around, this happens to be 2 pi. Remember, think about if 2 pi is equal to 360, we will split this circle up into fourths. So this is 0. If I take 1/4 of 2 pi, that'll get us pi over 2. This will end up equaling right here pi. Down here, this is 270 degrees is 3 pi over 2, and then we're left with 2 pi. If we repeat the circle again, then that'll get me 4 pi, right? 0 to 360 is 2 pi. We add another 2 pi. That'll take us around again and leave us with 720, which equals the same thing as 4 pi. So what I want you guys to realize is, okay, one time around is 2 pi. Another time around right here this is 4 pi. So in our unit circle, what that tells me is that this point right here, remember unit circle is a radius of 1, so from the origin to this point, r is equal to 1. That point right there is exactly at 1, 0. Because once again, we are dealing with a unit circle. So now we know what x, we have y, and we now have r. And that should get us to our answers, and we do the same thing. Our sine theta ends up being y over r. So we have ourselves 0 over 1. That equals 0. We have cosine theta is x over r, which is 1 divided by 1, which will end up equaling 1. Next up, we have tangent theta, which happens to be y over x. And so we end up with 0 divided by 1, which ends up equaling 0. And then we take the inverses of each. The inverse of sine is secant, is cosecant. So cosecant theta is equal to 1 over 0. And hopefully we now remember that that is undefined. There's cosecant theta. The inverse of cosine is sine. So as sine theta, we're at 1 over 1, which equals 1 again. And then for cotangent theta, let's take 1 over 0, which ends up equaling, you got it, undefined. All right, so that is how we will deal with the unit circle. Once again, you could use SOHCAHTOA. However, when the point is actually on the axis itself, you can't do SOHCAHTOA because there is no opposite and adjacent, right? There's no hypotenuse from the center. So that's why you need to make sure you know how to find sine, cosine, tangent using the equations that are necessary that we just used to solve these number 3 and number 4. The other thing that you're going to need to know in order to solve your problems for this homework assignment is you'll notice that there's some real life application problems and there's an equation that you're going to need to use. And if you look at the book, you'll find it and you'll actually see the equation there as well in an example problem. But for your real life applications, you're going to need to know this. D is for distance, and that's going to be equal to velocity squared divided by 32. And you're going to multiply that by sine times 2 theta. Okay, so this is the equation you're going to need to know in order to do some of the later problems in your assignment in 9.3b. Okay, so make sure you go back and take a look at those right there. And make sure you have that equation written down. Like I said, in the textbook, if you go back and look at the text, you will be able to see some problems there. It'll say example number 5 in your problems to help you solve the word problems out. Okay, so if you look at example 5 in section 9.3 examples, there's the equation, and you should be able to figure out, all right, what's velocity? You should know what that is. Theta, you should be able to find what theta is based on the problem. What angle are they dealing with? Okay, so it's making sure you properly know how to plug things in and use it. One last question that I wanted help you out with or go over on this, in case you need a little bit more help, is it says evaluate the function. We did this one in 9.3a. Well, how about this time in example number 2 for this one? Let's say we have cosine negative 210. And it says let's evaluate cosine negative 210 without using a calculator. All right, so let's start with our initial side once again, which is right here. We're going to use this again. So if you need to copy another one right here on the side, you can go ahead and do that. But let's go ahead and start right here. And if I'm going to go negative, I need to go clockwise. Moving down here, that is negative 90. We have negative 180. And then we have negative 270. So that's too much. So if this is negative 180, we'll go ahead and right here, this should be approximately negative 210. All right, so from here to here, we have ourselves negative 210 degrees. But remember, the thing is, we need to use and figure out what is our reference angle. And our reference angle is going to be formed from this, from the x-axis closest to our terminal side. Well, if this is negative 180, right? The negative 180 to negative 210 right here, that makes this 30 degrees. And we have ourselves, once again, if you haven't gotten this triangle down, our special right triangle of 30, 60, 90 is what we're going to have to use again. All right, so we have 30, 60, 90. And remember the sides right here. Opposite of 30 is x. Opposite of 60, x rad 3. And then opposite of the 90-degree side, our hypotenuse is 2x. Let's say we're dealing with, we're just dealing with the simple circle. Let's go ahead and say that one of the sides happens to be 1, right? The leg is 1. And so that'll make things a lot easier, where this will be 1, leg times rad 3, and our hypotenuse is 2 times 1, which is 2. So finally right here, we got ourselves cosine of negative 210. We'll go ahead and figure out, all right, well, cosine theta, right? Cosine of 30 is what we're going to end up figuring out right here. Remember, for cosine, SOHCAHTOA, we have adjacent, and adjacent side right here. And how about let's label the angles or the sides for you. This is the 60-degree side. Sorry, I don't know why I put the right triangle or right angle symbol there. But if this is 60, then that makes this side rad 3. Opposite of 90, we have 2. And then right here, this will end up being 1. Opposite of the 30-degree side. So once again, for our cosine theta of cosine of 30, adjacent is rad 3. Hypotenuse is 2. And so cosine theta is equal to rad 3 over 2. All right. There's one last thing we need to add in order to get our final answer correct. Remember yesterday, or when we took a look at the first part of this section, we have our mnemonic device that we use to figure out what is positive in our quadrants. First quadrant is A. The second quadrant is T or S, T, then C. For our mnemonic device being all students take calculus. And so remember, in quadrant 1, everything is positive. Sine, cosine, tangent, and the inverses. In quadrant 2 right here, only sine and cosecant are positive. So what that tells me that in my final answer right here, cosine in quadrant number 2 is going to be a negative answer. And so we need to make sure we add the negative to rad 3 over 2, and now we have our final answer. So if you got those problems wrong when you did 9.3a, don't forget all students take calculus to help you remember what is supposed to be positive in each quadrant.